Good morning, ladies and gentlemen, on this April 27th, 2020. Hope you guys all had yourself a wonderful weekend. And today we're going to pick up back with square roots because we're not yet done with radicals. While we've been talking about the opposite of square roots, squaring, how to rearrange square roots and radicals and exponents into different forms to better understand them, I thought we'd go back to radical equations for just a moment. Now, want everyone to remember that squares and square roots cancel each other out because they are inverse operations. That if I have this square root of x, and I square it, that obviously is going to give me x on the left side. But if I square the left side, I have to square the right side. And so x is going to be equal to 16 squared, which I believe is 256. Now, if we have something like this, the equations might look a little bit tougher, but it just functions the same. Before I take care of this 2x minus 4, I have to get rid of the square root. Because the analogy I like to use is, imagine your expression is like a cookie. Before you get to the center of this cookie, you have to work from the outside to the inside. You can't just take a cookie and eat the inside. That's a donut. Even with a donut, you still got to eat the outside first. So before I do anything, I have to take care of the square root. I have to take care of the stuff on the outside and work my way to the inside. So the opposite of a square root is a square. And so that's going to take me to 2x minus 4 is equal to 256, because we already know that from the last problem. Now, admittedly, you could take care of either one of these first. You could either add 4, since the opposite of minus 4 is an add 4, or you can divide by 2, since that's the opposite of multiplication. But I still like to work from the outside to the inside. Oh, excuse me. The opposite of a minus 4 is a plus 4. And so 2x is equal to 260, because 256 plus 4, 260. And then x is 260 divided by 2 is equal to 130. Now, if you have something like this, now I say, oh, well, I obviously got to get rid of the square root first. You do have to get rid of the square root. That is true. But does the square root cover the whole problem? No, it doesn't. You have this minus 20 on the outside, and if you're working from the outside to the inside, you have to take care of that minus 20 first. Well, do the opposite of a minus 20. Then do the square, then divide by the negative 3. Oh, it looks like I've got a kitty coworker right now. Oh, she's a little camera shy. She wants my attention, but she doesn't want to get in the camera. And so, square root of negative 3x, Missy, you know you're not supposed to be on the table, is equal to 15. Please excuse me. And I'm back. I apologize. My kitty cat was very attention-seeking. She pulled off one of the other computers onto the floor. And so, once again, opposite of this root is a square. So, negative 3x is equal to 15 squared. Because a square root and a square cancel each other out. 225. And 225 divided by negative 3 gives you x is equal to a negative 75. And so we've solved an equation pretty much the same way. Give us some good practice, but there are different steps involved. So I have something like this. If I look at this check for understanding, it says, how are these equations different? Which one has a solution of x is equal to 29? Now, there's multiple ways that we can work on this one. Well, tackling the first question, how are these different? Well, they're different because there's different orders to the equation. They all say 2x minus 4, and they all have a square root. But this is the square root of 2x minus 4. This is the square root of 2x. Then you have a minus 4. And this is the square root of x minus 4 times 2. So you'd have to do the same operations to undo all of them, but you do have different ways that you can do this. Now, if you want to figure out what this is, then you have a solution of x is equal to 29. Two ways you can tackle that is, first, you could just do the inverse operations and just figure out which one has an x is equal to 29 at the end. Or you can just take this x is 29, plug it in for x, and see if it works. Now, what is 29 times 2? Let's just tackle the first one. Let's see if it's the first one. What's 29 times 2? 29 times 2 is a 58. It means 58 minus 4 square root is equal to 10. Now, ladies and gentlemen, is that true? It's definitely not, because that means that the square root of 54 is equal to 10, and that's definitely not true, so I know it's not A. Let's try the second one. Well, we'd start the same way, and we know that, alright, square root of 58 minus 4, that is a minus sign, is equal to 10. Well, square root of 58 doesn't give me a whole number, and we could break it down other ways, but this is a whole number, and if you aren't going to get a whole number minus something, well, minusing 4 isn't going to suddenly make it a whole number, so it's definitely not this. And so by default, we'd want to say that, alright, it's got to be C. Well, let's double check it. 2 times 20, what's 29 minus 4? Well, 29 minus 4 is 25. The square root of 25. 5, that's 2 times 5. Boom, 10 works. Alright, good job. So we know it's C by 2 ways. We can eliminate the other ones by plugging in 29 to see if it works or it doesn't work. Or we can solve it through using our inverse operations. Like this would have been square root of x minus 4 is equal to 5. X minus 4 is equal to 25. X is equal to 29. See, would have worked either way. Alright, so if we have a radical equation, this equation is a lot different from the other ones. It looks a lot more intense, and one thing we definitely know is that I've got an x on both sides. And so this problem is probably going to take us the rest of the time, but let's see if we can work it through first. Now, the first thing I always want to do is try to get where it's the radical on one side and everything else on the other. So this 21 has to come to this side, because I want a radical on one side, the root on one side, and everything else on the other one. Now, I can't move the 7 because it's underneath the radical, so it has to stay there. But what's the opposite of a plus 21? That's right, ladies and gentlemen. Let me write an X there. Let me just write over it. It's an ugly thing, but a minus 27. My brain blanked. Now, would we say the opposite of a square root was? That's right. Squaring. Now, if you square the left side, it's not going to be x squared minus 27 squared. You have to do the box method, or you could FOIL it. Either or would work for you. So I have x minus 27 and x minus 27, and so this is x squared, then minus 27 times x gives me a minus 27x. I think we've done the box method before. And if I add all this together, that's going to be x squared minus 54x plus 729. Yes. So this means when this square root and that square cancel out, x minus 7 is equal to x squared minus 54x plus 729. Now, at this point, it goes back to how to solve a normal quadratic equation. I want everything on one side and 0 on the other, so I can either factor or do the quadratic formula with my quadratic. So I've got to minus this x and plus this 7, so they both would go to this side. And so when doing this, and moving my stuff up here, my left side is obviously going to be 0, because everything there is gone. And my x squared doesn't change. But I now have a minus 54x minus x. So that's a minus 55x, since it gets 1 less. And 729 plus 7 now gets me a 736. Now at this stage, when you have x squared minus 55x plus 736, we've been doing this a lot today, but you've got two methods you can do. You can either A, factor it, see what two things multiply together to give you a 736, and add together to give you a negative 55x. Or you can do the quadratic formula. Now, quadratic formula would be a little bit easier in the long run. I'd be able to see every single step, but for the sake of time, for the sake of this time, I'm just going to factor it. I've done this before. I know what two things multiply together to give me a 736 and add together to give me a negative 55. It is a negative 23 and a negative 32. So I have x minus 23 times x minus 32 is equal to 0. Now this is a very long and in-depth problem, but we're almost done. I know from the zero product property that if I have two things that multiply with each other to give me 0, I can set them each individually to 0 and then solve. So x minus 23 is equal to 0. Well, what's the opposite of a minus 23? X is equal to a positive 23. And if I have an x minus 32 is equal to 0, well, what's the opposite of a minus 32? A positive 32. So, there's my answers, ladies and gentlemen. When working on this problem, the two numbers that will solve this equation is a 23, where I can plug 23 into both, and a 32. Now for this final one, I'm just going to give you the first step. Remember, take this plus 3 over the other side, and then I want you to solve for both of them. X plus 1 is equal to an x minus 5. Do your box method. Multiply the 2, x minus 5, and x minus 5. Ladies and gentlemen, your answer that you should get at the end is x is equal to 3 and x is equal to 8. Now, ladies and gentlemen, take the time, work on this problem, go back and rewind the video to figure out exactly, alright, I need to do this step, then I need to do this step, then I need to do this step, and you'll have it. Ladies and gentlemen, I hope you had yourselves a good weekend, and I hope you have yourselves a good week. Hopefully this continues to hopefully this blows over quickly. Ladies and gentlemen, have yourself a wonderful Monday.